This is section 10.4, exponential functions. An exponential function is different than what we've been dealing with because the base is a and our exponent is now our variable x. So we do have to have an a base number, that is greater than 0 and not equal to 1. This is what the exponential function looks like. And if we notice, this is y equals 2 to the x. So I've put some values of x here that show up as these red dots, and this is what we get: 1/4, 1/2, 1, 2, 4. So we see that ultimately this is going lower and lower and lower. These little tiny fractions, it will never actually reach the x-axis but get infinitely close, and it will go infinitely high this way pretty quickly. So that's what an exponential function looks like. You can put it in your calculator, 2 to the x, and this is what you'll get there. If we are solving exponential equations, if possible, we're going to write so that both sides have the same base. In other words, if we had 9 to the x equals 27, we want to rewrite 9 as 3 squared. Now we've got both bases being 3. We could rewrite, and we also have to rewrite 27 as 3 cubed. So remember the rule for power to power, we multiply. So now we've got 3 to the 2x equals 3 cubed. Once we get to this point, if the bases are the same and we're saying these two expressions are equal, then the 2x has to equal 3. And we write that without the bases, and we solve, and we get x equals 3/2. So that's something we'll see in some of our problems, that technique. We have some interest formulas here. Simple interest is the product of the principal times rate times time. So I equals PRT. We've used that probably before. Now we're going to talk about compound interest, and our formula looks like this. A equals P times 1 plus R over M raised to the T times M. T is the time in years. M is the number of times you're going to compound it. So that's either like quarterly, semi-annually, monthly, daily, that sort of thing. And R is your interest rate. So that's that formula. We're going to talk about the number E. And the definition, or where it comes from, 1 plus 1 over m raised to the m. As m gets larger and larger and larger, it becomes closer and closer to the number e. And the e, an approximate value, is this number here. It's an important number, especially in exponential functions, and we have it on our calculator. You see that on the ln key, it is above it, says e to the x. So if you hit second ln, you'll get e and a caret, and you'll hit the 1 key and enter, and you should get this on your calculator. You may not actually have the 1 up here. If you have an older calculator, you'll probably have e to the 1. Newer forms have the actual exponent box up there. Okay. Continuous compounding does use the e in that. It is principal times the number e raised to the exponent rate times time. And that would give you how much money totally. All right, so that's our notes for this section. Let's look at our problems. All right, number 1 says graph the equation on paper and choose the correct graph. So you really could do this one without your calculator, and I think it's a good idea to try to do that. On some it won't be as easy, and you could certainly use your calculator. But 6 to the x, remember to choose 5 values for x, getting a couple of negatives, 0 and 1 and 2. So these are the numbers I would try. And 6 to the negative 2, just to remind you, 6 to the negative 2 is the same as 1 over 6 to the positive 2, which is 1 over 36. So we go through and we get those numbers, we kind of sketch that out in our paper, and we get an idea, and we definitely can match that. Okay. You could do the same with 3 to the negative x, but I did this one on the calculator, so that can show you what that looks like. And I'll get that down there. So 3 to the negative x. What we should notice is it's doing opposite because it is a negative exponent. So we're going down this way. Okay. 5 minus 2 to the negative x. Just be sure that when you put that in y1, either you've got a caret and you have it like that, or 5 minus 2 and you have a little box up there. So do that and you should be able to see that one as well. I'm just practicing looking at those in the calculator or by hand. Alright, 3 to the x equals 1 over 27. When we have a fraction, we should think negative exponents. So we're going to change 1 over 27 to 3 to the negative 3. Now that our bases are the same, we can just take the exponents, set them equal. We have solved our answer. There's our answer. 81 to the 5x equals 27 to the x plus 4. 81 and 27 can both be written as a base 3 raised to some power. 3 to the 4th is 81, 3 cubed is 27. We still have these, but remember, power to power we multiply. So this is 3 to the 20x equals 3 to the 3x plus 12. Multiply that. We then take the exponents, set them equal. We have 17x equals 12. So x is 12 over 17. 16 to the x plus 2 equals 64 to the 2x minus 7. Each of those can be written as a power of 4. 4 squared is 16, 4 cubed is 64. Then we multiply the powers, so we have 2x plus 4 and 6x minus 21. Set those equal. X has to be 25 over 4. This one, e to the negative x equals e to the 8th to the x plus 9. Go ahead and multiply the powers. So we have e to the negative x equals e to the 8x plus 72. Set the exponents equal. Subtract 8x this way and then divide by negative 9. You get x equals negative 8. Solve this equation, and again we're going to change 36 into 6 squared, multiply the power, so we have 6 to the 4x equals 6 to the x squared minus 5x. So we get x squared minus 5x equals 4x. This is quadratic in nature. Bring the 4x over here. So I found a small error there and corrected it pretty quickly. So x squared minus 5x equals 4x. When we subtract the 4x, we have x squared minus 9x equals 0. We factor out the x, so x times x minus 9 equals 0. X equals 0, and x equals 9. We have that one, and we have that one. So your answers up here will be 0, 9. Okay? All right. Find the interest earned on $15,000 that's invested for 5 years at 7% interest compounded as following. So you have 5 different problems to work here. Here's the original problem formula. So if we plug in the 15,000, the 0.074 interest, and for annually, those are both, this is a 1, that's a 1 part of the formula, but 1 here times 5 years. We do that calculation and get 21,038.27. That's how much money we end up with. So to find out how much the interest was earned, take this number we find here and subtract your 15,000. You get 6038.28. And if you want to do this on the calculator, be careful trying to put all that in at once. So if you're doing it, let's quit out of this and clear. So what I like to tell people, because it's not bad with the ones, but let's just do it and make sure. Start in the middle of the parentheses. So if we had 0.07, and say it wasn't a 1, but I'm going to do the whole thing, divided by 1 and hit enter, plus 1, enter, raised to the 5th power, enter, times 15,000, enter. And so that's where we're going to get that. So start in the inside, get this, then add 1, then raise it, ultimately then multiply by the 15,000. You do that with each of these. The only thing you're changing, semi-annually, that number will be 2, and that number will be 2. Quarterly, those will be 4s. Monthly, those will be 12s. And continuously, you use this formula, the PE to the RT, and so that's how you would do that. And the interest is 19,260.38 minus 15,000. So that's how I got all of these numbers. Okay, just be careful on that. All right, Chris Lynch plans to invest $500 into a money market account. Find the interest rate that's needed for the money to grow to $1,300 in 12 years if the interest is compounded quarterly. So we're not trying to find out how much money, we're trying to find out what's the interest rate we need to get to that amount of money. So here's your basic formula. We're going to plug in $1,300 for the amount that we want to end up with, $500 for the principal, 1 plus R we don't know, quarterly, so 4 goes there, 4 goes there, and 12 is the time. So let's do what we can. We want to isolate this, get this 500 out of here. So we'll divide both sides by 500. Simplifying, we get 13 over 5 equals 1 plus R over 4 raised to the 48. I went ahead and multiplied that. Well, I can't do anything as long as this R is locked up in here. So let's take the 48th root of that, and that will get rid of that power. Now on your calculator, let's clear this. So if you go to, because you need that to be able to do that for the left side over here. So if we go to math, and we have number 5, the nth root of anything. So we can look at that. So let's hit 48, then hit math, and hit number 5. So we've got the 48th root of 13 divided by 5, and hit enter, and you get this number that I have here. So again, that was math. You actually put the root first. So you put the root, and then you choose math and choice 5, and then put in whatever the base is. So that's how we got that. So now we have that number equals 1 plus R over 4, because when you take the root of anything to some power, those cancel out. Subtract the 1 on both sides. So here I'm showing that I did that, and I took away the 1, and then I multiplied both sides by 4, and that gave me 0.08, and this long number is R. If you want to round that to actual percent, remember you move the decimal 2 places, and I believe it says to round to the nearest percent. So your final answer here is 8%. So you can go over that, the math of that, and you can certainly use your calculator to do a good portion of it. And that should get you through 10.4. Okay?